You are sitting still right now, or at least that is what it feels like. Your chair is not moving. The floor beneath you is not moving. The walls around you are exactly where they were a moment ago, and a moment before that. Everything is fixed. Everything is where it belongs. This is the world as your body understands it, solid, stable, measurable. Now here is the first thing I need you to sit with. The room you are in is moving, not because of an earthquake, not because of wind. The room is moving because the space it occupies, the actual fabric of reality that the walls, the floor, and your body are embedded in, is stretching. Right now, at this moment, without pause, without any force you could stop, redirect, or even detect with your bare senses. The universe is expanding. You have probably heard that before. It sounds like a textbook line, something a teacher says before moving on to the next slide. But I want you to stay with it, because most people hear those words and picture the universe the way you picture a balloon being inflated. A thing with an inside and an outside, a skin that stretches, a center somewhere, an edge somewhere else. None of that is right. There is no center. There is no edge. There is no outside. There is only space. And space is getting larger in every direction simultaneously, not because something is pushing it from beyond, but because expansion is simply what space does. It is not moving through anything. It is the thing that everything else moves through, and it is growing. Stand outside tonight, if you can. Look up. Pick a galaxy, any smear of ancient light. It does not matter which one. Every single galaxy you could possibly point to, beyond the local group of galaxies gravitationally bound to our own, is moving away from us. Not because those galaxies have engines. Not because some explosion flung them outward long ago and they are still coasting. They are moving away because the space between us and them is accumulating. New space, generated continuously, inserted between us and everything else, like pages being added to a book that no one is writing. And here is where it starts to feel wrong. The farther away a galaxy is, the faster it appears to move. A galaxy 1 billion light-years away recedes from us at a certain speed. A galaxy 2 billion light-years away recedes at roughly twice that speed. A galaxy 10 billion light-years away recedes even faster. Keep going far enough, and you reach a distance where galaxies are receding from us faster than the speed of light, not breaking any law, not violating physics. Nothing is moving through space faster than light. The space itself is just being created between us so rapidly that the distance grows faster than light could ever cross it. Those galaxies are not going anywhere. They are just becoming permanently, irrecoverably unreachable. One by one, over billions of years, the lights of the universe will go out, not because stars die, but because their light will never reach us again. That is not a metaphor. That is the structure of the universe you live in, and the force doing it, the thing physicists call dark energy, is not a force in any sense you would recognize. It has no source you can point to. It has no mechanism anyone fully understands. It does not weaken with distance. It does not obey the inverse square law the way gravity does. It is not concentrated anywhere. It is everywhere, at equal strength, embedded in the fabric of space itself. And as space grows, so does the total amount of it. The more space there is, the more dark energy there is. The more dark energy there is, the faster space expands. The faster space expands, the more space there is. You are living inside a feedback loop with no break and no ceiling. And we have known this for less than 30 years. In 1998, two independent teams of astronomers set out to measure how fast the universe's expansion was slowing down. Everyone assumed it was slowing down. Gravity, after all, pulls things together. The Big Bang had flung everything outward, and gravity should have been gently, patiently pulling it all back, not to a crunch necessarily, but at least to a coast, a deceleration, a universe running out of momentum like a ball rolled across carpet. Both teams found the opposite. The expansion is not slowing down, it is speeding up. It has been speeding up for approximately 5 billion years, and whatever is causing it, this dark energy, accounts for roughly 68% of everything that exists. Not 68% of matter, 68% of everything. Matter, energy, all of it combined, is the remaining 32%. The dominant substance of the universe is something we cannot see, cannot touch, cannot collect, cannot even define with confidence. And it is winning. You are not sitting still. You never were. Let's build this slowly, because the only way to feel the size of what we are talking about is to walk into it one step at a time. Start here, Earth. You know this one. The circumference of Earth at the equator is about 40,000 kilometers. If you drove a car without stopping at highway speed, it would take you roughly 17 days to circle the planet once. That is your baseline. That is the biggest thing most humans will ever directly move across in a lifetime. Now step back. The distance from Earth to the Moon, the only other world human beings have ever stood on, is about 384,000 kilometers. You could fit every planet in the solar system in that gap with room to spare. The Moon feels close. It is not close. Step back further. The Sun is 150 million kilometers away. Light, traveling at 300,000 kilometers per second, takes 8 minutes to reach us from the Sun. That means when you look at the Sun, something most people have done thousands of times, you are seeing it as it was 8 minutes ago. Not now. 8 minutes ago. The light entering your eyes right now left the Sun before you started reading this sentence. Now step back further, much further. The nearest star to our Sun is Proxima Centauri, sitting at about 4.2 light-years away. That means the light from Proxima Centauri takes 4.2 years to reach us. If Proxima Centauri disappeared tonight, blinked out of existence right now, you would not know for 4 years and 2 months. You would keep seeing it. You would keep looking at a star that no longer exists because its last light is still traveling toward you. In the Milky Way galaxy, your galaxy, the one Earth and the Sun and Proxima Centauri all belong to, is roughly 100,000 light-years across. If you somehow traveled at the speed of light in a straight line across the Milky Way, the journey would take 100,000 years. Not 100,000 years of travel time that feels shorter due to relativistic effects. 100,000 years at the fastest speed the universe permits anything to travel. And the Milky Way is not large as galaxies go. It is average, mid-sized. The kind of galaxy that does not make lists. IC 1101, one of the largest galaxies ever catalogued, is approximately 6 million light-years across, 60 times the diameter of the Milky Way. Place it where our galaxy sits, and its edges would engulf the Andromeda Galaxy, our nearest large neighbor, with room left over for a dozen more. Now here is where the scale stops feeling manageable. The observable universe, the sphere of space from which light has had time to reach us since the Big Bang, is approximately 93 billion light-years in diameter. Not because the universe is that old. The universe is only 13.8 billion years old. but space expanded while the light was traveling, stretching the distances. So the light from the edge of the observable universe comes from a region that is now 93 billion light years away, even though it was almost on top of us when the light first left. Inside that 93 billion light year sphere, there are an estimated 2 trillion galaxies. 2 trillion, each containing, on average, hundreds of billions of stars, each star potentially hosting planets, and each planet potentially hosting. You do not know. We do not know. We have one data point. It is you reading this. Pause on that for a second. But here is the thing about the observable universe that I need you to hold carefully, because this is where dark energy transforms from a physics concept into something that feels like a verdict. The observable universe is not the universe. It is only the part we can see. The universe beyond that, the part whose light has not reached us or never will, could be infinite. Current cosmological models do not rule out infinite space. They do not confirm it either. But the honest answer is, we do not know where the universe ends. We do not know if it ends. And in every direction beyond what we can observe, space is still expanding. In regions we will never see, the galaxies are still receding from each other. Space is still accumulating between them. Dark energy is still doing whatever dark energy does, silently, at full strength, in places no signal from Earth will ever reach. Now here is the gut punch. The observable universe, the full 93 billion light-year sphere, with its 2 trillion galaxies, is already shrinking, not in size. The sphere is getting larger as time passes, and more light has time to reach us. But in terms of what we will ever be able to interact with, the universe is closing. Dark energy is accelerating expansion so efficiently that light from increasingly distant galaxies will never complete the journey to us. The sphere of everything we could ever influence, ever reach, ever receive a signal from, that sphere is contracting, and galaxies are being pushed beyond the cosmic horizon, one by one, permanently. In approximately 2 trillion years, if any observer exists anywhere in our galaxy's remains, the night sky will be nearly empty. Not because stars have died, though many will have, but because every other galaxy will have crossed the horizon. The universe will look from inside the Milky Way like a single island of stars surrounded by perfect, permanent, lightless nothing. They will have no evidence that other galaxies ever existed. They will have no way to discover what we know right now. And here is the question that should keep you awake tonight. What if we are already in someone else's dark? There is a version of this story that ends in despair. Infinite expansion, cosmic isolation, a universe growing darker and colder and more spread out until even the atoms stop moving and everything settles into a final, featureless quiet that physicists call the heat death. The end state of maximum entropy, where no work can be done, no signal can be sent, no difference exists between one place and another. That ending is probably real. The physics points there. Dark energy shows no sign of reversing. But before you decide what to do with that, I want to tell you something about where you are standing in this story. Because timing matters more than scale. You exist in what cosmologists sometimes call the stelliferous era, the age of stars. The period in the universe's history when matter has condensed into galaxies. Galaxies have formed stars, and stars are burning with enough energy to warm planets, to drive chemistry. to make possible the conditions under which something like awareness can assemble itself out of carbon and water and time. This era began roughly 100 million years after the Big Bang. It will end, in a cosmological sense, in about 100 trillion years. We are 13.8 billion years in. We are early. Not in the way a child is early to a party they will eventually leave. In the way that the first microbe was early to life on Earth, present at a moment so foundational that almost everything which will ever happen has not happened yet. The universe is not old. By its own timescale, it has barely started, and we are here, in the opening chapters, already asking what it means. That is not nothing. That is extraordinary. Every culture that has ever existed has pointed at the sky and felt something, not always the same something. Sometimes fear, sometimes reverence, sometimes a navigational instinct or a mythological reflex, but always the same upward gesture, always the same recognition that the night contains more than the day can hold. We have been reaching toward the scale of this for as long as we have been human. We just did not know how far it went. Here is what dark energy means for us, not as a physics equation, but as a condition of existence. We are not the center of anything. The universe has no center, but we are also not peripheral, because there is no edge, there is no periphery. We are simply here, located, present, at a particular coordinate in a fabric that extends beyond comprehension in every direction, at a particular moment in a timeline that stretches from a beginning. We can only partially reconstruct toward an end we can only theoretically describe. And we can describe it. That is the thing. That is the part that does not get said enough. In the roughly 300,000 years that anatomically modern humans have existed on this planet, we have gone from reading animal tracks to reading the expansion rate of the universe. We have built instruments sensitive enough to detect the faint thermal afterglow of the Big Bang still echoing through the sky. We have measured the acceleration of cosmic expansion to several decimal places. We have given a name, dark energy, to a phenomenon that constitutes most of what exists, even though we cannot directly observe it, touch it, or fully explain it. We know the universe is expanding. We know it is speeding up. We know the horizon is closing. We know we are made of the same atoms forged in the cores of stars that lived and died before the sun existed. We know our sun will swell into a red giant in approximately 5 billion years and end life on Earth as a side effect of its own dying. We know all of this. We are the universe knowing things about itself. Whatever dark energy is, whatever unnamed force is stretching space in every direction at every moment without rest, it did not produce anything capable of noticing it until us. Or if it did, we have not heard from them. We are the only confirmed data point of awareness looking back at the thing that made it. The expanding dark does not care about that. It will keep expanding whether we are here or not. It will keep pushing galaxies past the horizon. It will keep diluting the light. It will keep doing what it does in regions we will never see, at scales we will never measure, for durations that make our entire civilization look like the flash of a camera in a dark room. But for right now, in this particular moment, in this particular sliver of the stelliferous era, on this particular planet orbiting this particular medium-sized star, on the outer edge of this particular spiral galaxy among 2 trillion others, you looked up, and that is the only answer the universe ever got.